asked to determine negative f of a. We can do it in two steps. First of all, I want to find f of a, which is 6a minus 5 divided by 7a plus 2. That's my first step. Then they're asking us to find the opposite of f of a, so all we have to do is put the minus in front. Nothing else is required. We do not have to do anything else. If you decide to distribute, which I do not recommend, if you decide to distribute a negative sign, you cannot distribute it to the top and the bottom. That will be incorrect. So if you want, that's why I emailed you back and I said do not distribute it to both. So you can, I would not do this, but you can write this. There is no need. We do not want to have negative leading coefficients anyway, if possible. It's not wrong, but there is no need to do that. Yes, can I copy that function? So 2x squared minus 50 over over 6x squared
plus 7x minus 3.
Perfect. Very good. So we are asked what? We're asked to graph this function and show everything step by step. Okay. We have a long list. Instead of going through the list, all you have to do is fill out the table. Once you fill out the table, once it's filled out, you know you're done. Now, I do need to do a little bit of work because I cannot determine the domain before I do what? Before I factor the denominator. So I have to factor the denominator. Excellent. So I have 6x squared plus 7x minus 3. I don't know which method you prefer. I prefer the method of multiplying 6 by negative 3, which is negative 18. And then I need to find a 7, which will be a 9 and a negative 2. But that's the method I like. You do not have to wait for me. You factor it the way you like. I'm showing you the method I like. And then I factor by grouping, intentionally not looking at the other two. So from 9x squared and plus, from 6x squared plus 9x, I will factor out a 3x. What is left in parentheses? And the answer is 2x plus 3. Very good. And what has to come out from the other two? Otherwise, I can't continue. Mandatory. I don't even look. It has to be a 2x plus 3. Now I look. I need a sign and a factor. Perfect. Negative 1. So then the factor form will be 2x plus 3 and 3x minus 1. So I go back. I rewrite the function. So this is f of x, 2 x squared minus 25 divided by 2x plus 3, 3x minus 1. Let's stop for a moment. Do we understand all steps? I didn't do much. The only thing I did was just to factor the denominator. Are we okay with this? Everyone? Yeah. Perfect. Okay, so of course I will factor out the numerator as x plus 5 and x minus 5. Now I am able to identify the domain. I'm also able to identify the x-intercept right away. That's why I factor the numerator as well. And also I factor to see if there is a factor that goes away from top and bottom. That's also true. So can anyone give us a domain? To negative 3 halves. Very good. Yes, 0, 1/3. That's it. If you want to write it separately using interval notation, it's fine. At this point, since no factor from the denominator disappears, I will immediately write that x equals negative 3 halves is a VA and x equals 1/3 is a VA, which immediately draws this. That's my next conclusion. So if the function is rational and it's not defined at negative 3/2 and 1/3, then I know that, and those factors do not disappear, I know immediately that these two are vertical asymptotes. Then I know immediately that these must be infinities. What I don't know is about those infinities, what I don't know. Yeah, but it's not a problem. So this is negative 1.5, I'm going to use negative 1.6. And this is negative 1.5, I'm going to use negative 1.4. This is 1/3, which is 0.3, I'm going to use 0.2. And I'm going to use 0.4. As you see, I put these up there. I'm not going to plot any of this. I'm just going to use these numbers to get the sign of these infinities, nothing else. Okay, so let's plug them in, and I prefer the factored form. So with negative 1.6 and negative 1.4, I hope you agree that this is positive, right? And this is negative. And with negative 1.6, this will exceed, it will be negative 3.2. So this will be negative. And with negative 1.6, this will be negative. So I see three negatives. The sign will be. Then with negative 1.4, this is still positive, this is still negative. This is still negative, but with negative 1.4, this will be larger, so this becomes positive. So now I see two negatives. To the right-hand side is positive. Now with 0.2, I'm here with 0.2. This is positive, this is positive, this is negative, because 0.2 minus 5 will be a negative number. And this 0.2 times 3 will be negative 0.6 minus 1 is still negative. So the sign here is, very good, two negatives. That's okay. With 0.4, this is positive, this is negative, this is positive, but 0.4 times 3 is 0.12, right? And still negative. 0.4 negative, 0.4 positive, 0.4, right? 3 times 0.4 is 1.2. Sorry, because it didn't make sense. Oops. So this is positive. So on the other side is negative. How did I figure that out? So let me explain how I thought that obviously they cannot be plus plus, they cannot be negative either. Both situations. Only because there is no square term. And normally a squared term does that with plus plus and minus minus. So it's unlikely that this would be plus plus or minus minus both. Okay? So we determined a lot so far. We determined the domain. We determined the vertical asymptotes. We determined the behavior near the vertical asymptotes. So now I need the x-intercepts and the y-intercept. For the x-intercept, remember, 0, 0, 0, negative 50 over negative 3. 50 over 3. For the x-intercept from here, you can determine them immediately. We know that a fraction is 0 only when? Right, so where is numerator at 0? That's it, so let's put them in the table. Once you fill out the table, you're done. So negative 5 and positive 5 and 0 and 0. Great. And now we have the end behavior. By the way, can this function be symmetric with a vertical asymptote at 3/2 and 1 at 1/3? No. No. But I have to write that something.
So that would it be symmetric if that was
It's possible. It's possible that it's symmetric if it has the same vertical asymptotes. But if it's one at negative 2 and the other one at positive 3, no. Okay, so now with the horizontal asymptote, what type of rational function is it? Because if you say type 1, then the horizontal asymptote is leading coefficient over leading coefficient. If you say type 2, the horizontal asymptote and behavior is 0.
0.
Type 1. Same degree over same degree. So the leading coefficient is?
1/3.
Yes, 2 over 6, which is 1/3. And that is the end behavior, and you're done. 1/3, 1/3, y equals 1/3 horizontal asymptote. The only thing that does not fit here is the symmetry. So again, I'm going to cut it short. I'm going to say that f of negative x does not equal f of x and does not equal negative f of x for the reasons we just discussed. Note symmetry. So now I'm ready to graph. I do not care for any calculations. I'm not going to waste my time on anything and look anywhere else but here. So let's indicate what this means and what it tells us. Let's try to understand this. The function is coming from approaching 1/3, crossing the x-axis at negative 5, 0, going to negative infinity. It's fine. So from 1/3, crossing at negative 5, 0, going towards negative infinity. On the other side, from positive infinity, crossing at 0, 50 divided by 3 is what? 1/6? Yeah, 16. Okay, fine. So it's coming from positive infinity, crossing the y-axis at 0, 16, ... and going to positive infinity. Okay. On this side, it's coming from negative infinity, crossing at 5, 0, and approaching 1/3. Does it make sense? Let's do it one more time. From 1/3, crossing the negative 5, 0, going to negative infinity. In the middle, from positive infinity, crossing the y-axis, going to positive infinity. And on the left-hand side for you, negative infinity, crossing that 0, that 5, 0, approaching 1/3. No big deal. So I want you to spend 3 minutes on these functions. I don't want you to do anything else. Okay? They are important functions, and once you understand what's happening here, you should have no difficulties. When we graph a function with asymptotes, the first thing we have to graph always are... Exactly, very good. So I'm going to say that this is 1/3. I'm lying to you. So this is y equals 1/3. And then 1/3 again, but this is x. And then on the other side, negative 3/2. So if this is 1, okay, I'm going to say this. So this is x equals negative 3/2. After I plot the asymptotes, I will deal with the points. Negative 5, 0. I'm going to say this is negative 5, 0. Then 0, 50 over 3. Forgive me, I'm going to say that this is here. The units are a little off, of course. So this is 0, 50 divided by 3. Then we have 5, 0. I'm going to say this is 5, 0. And now I'll put it all together. Ready? From 1/3, crossing, going to negative infinity. From 1/3, crossing, going to negative infinity. From 1/3, crossing at negative 5, 0, going to negative infinity. In the middle. From positive infinity back to positive infinity, crossing here, I doubt. It's not going to happen. I'm assuming this is going to happen. This is more likely. This is very difficult. So these functions on their domain, they're smooth continuous functions. If you twist your wrist to graph it, it cannot be right. So I'm kind of twisting my wrist to do this. See, I can't. But this is very smooth. Yep. So we'll check with the graphing calculator. We don't have tools in pre-calculus to determine max min. So you have to take calculus, and I'll show you how to do this by hand. Okay, so then from negative infinity, cross at 5, 0, and go to 1/3. So this is the function. What was it? 2x squared minus 50 over 6x squared plus 7x minus 3. Yes, we should look at the graphing calculator because we need to determine that minimum. So let's take a look and just do that. In y equals, clear if you have whatever. Do not forget to put parentheses around the numerator and parentheses around the denominator, and minus 50. And divide by, in parentheses, again, 6x squared, and plus 7x, and minus 3. Minus 3, yeah. close the parenthesis. The calculator is not as smart as you are. It will not know to graph a horizontal asymptote of 1/3. So you have to put it in as a second function. Now, I see that the function crosses the y-axis above 16, right? So I'm going to change the viewing window. I don't really care for too much of a negative y-axis. I don't care for that. Negative 10 is fine. Maximum for x is fine because of 5 and negative 5. But y minimum I don't really care for that much. But y maximum, yes, I'm going to go to 30 with a scale of 5. And let's see what happens. I don't know if you teach me, I did not research this, my apologies, how to make the graphing calculator or this software to present the vertical asymptotes. So if you research it for me, that would be great. So as you see here, I didn't care for this part because we knew everything about it, but we needed to see this mainly. So it's coming down to a certain minimum, and then it turns, of course, and then it crosses at 50/3. So as expected, this is the situation. Not this, not a turn here, but comes to a minimum. And I want to determine this minimum. And this minimum obviously is somewhere between, this is -3/2. I'm going to say between -1 and 0. So let's go back to second and calc. And I want the minimum, which is 3. And I want between -1 as a left bound, and I want 0 as the right bound, and just give me the minimum. So the minimum is when x is -0.6, and the minimum is 9.8, roughly. So as expected, -0.6, 9.8. And I will put that in the table. That's the last thing I need in the table. So it's right here. So -0.6 and 9.8, and I will say local, oh no, I meant min, local min. Yes, it's one of the required items on the list. Yeah. So I put it here as well. You don't have to go back and correct anything. I'm fine if you just give the options and then you check with the calculator, and that's how it should be. We don't know at this point where the minimum is, so it could be normally if there is some sort of symmetry, it can turn on the y-axis. If there is no symmetry, it will not really turn on the y-axis. Very good question. Sarmad, is this okay? Good, that saves us time because I had in mind to go over a problem like this anyway. Yes, Mike, you had another?
Yeah.
Got it.
That's a word problem.
That's fine.
It's,
Can I copy it or?
yeah. Just write down the details of it.
So,
It's like Ben was walking at 4
oh, so the number 5.
Yeah.
Okay, so so he's walking at 4 miles per hour. So I'm gonna, yes?
And he's been walking for an hour and a half.
Okay, so 1.5 hours at the speed of 4 miles per hour. And
Amanda's been walking.
Amanda at 7.
When does Amanda catch up to Ben?
And we don't know the number of hours.
Yeah.
We don't,
I
right?
think it's just like she starts walking at 7 miles an hour. How long until she catches up to Ben?
Okay, so now the question is, do they start at the same time?
I don't think so. I don't think they do. I think Amanda starts walking to try to catch up to Ben. That's what the- So it's like when
So how far apart are they, time-wise?
an hour and a half. Like Ben's been walking for an hour and a half.
Oh, okay, so
Amanda
that's what
just started
okay.
walking.
So he starts now, he walks for an hour and a half, and then Amanda starts, right, after an hour and a half, and she is much faster than he is at 7, and we expect her to catch up with him at some point in time. Is that the understanding? Okay, perfect. Do we understand what the problem is? Should I repeat? Should I repeat? Yes, okay. So the first person starts walking at 4 miles an hour. And an hour and a half later, the second person starts walking, trying to catch up with him, with the first person. Okay? So the question is, how many hours does Amanda need to walk till she catches up with him? till she passes by him, has a little chat, something like that. Okay, ready? So here's the first person at 4 miles per hour, and I'm going to call this R1, speed 1, a rate of change of distance with respect to time. So this is point A, and I'm going to say that they meet, or she catches up with him at point B. And her speed or rate is 7 miles an hour. So the distance covered by the first person will be 1.5 plus some time. Let's call it, let me call it T. That's the best. So obviously the distance AB by the first person must equal the distance AB by the second person. So they have to cover the same distance. They both started at point A, but one of them has a head start of an hour and a half. So it doesn't matter when they start, both of them have to cover distance AB. The first person covers distance AB in R1, so distance equals rate times time. This is an assumption, there is an assumption here of uniform motion, which we know is not entirely correct. It's not possible unless I walk till I get to 4 miles an hour and then I'm uniform. My speed will be uniform. But anyways, we assume that it's uniform motion and distance equals rate times time. So the first person covers the distance AB in an hour and a half plus, we don't know, times rate R1. The same distance is covered by person 2 with rate R2, but this time she only uses time T. She uses time 1.5 hours plus time T. But she only uses time T, which we don't know what it is. We do have R1, we do have R2. Do we understand the equation? Yes? So is it clear why the two distances have to be the same? Okay, so R1 is 4 miles times 1.5 plus time T. R2 is 7 miles times T. I distribute, so that's 6 plus 4T equals 7T, or 6 equals 3T, so T equals 2 hours. You do not need anyone to tell you whether this is correct or not. Before you plug it in, just make sure you check. The two distances have to be the same with 2 hours. So if 4 times 3.5 equals 7 times 2, then we are in business. So it's correct. Again, you don't need anyone else to tell you anything. So 3.5 multiplied by 4. If that equals 7 times 4 times 2, which is 14, then we're done. So the time needed, Elmer, please. The time needed for Amanda to catch up with her friend is 2 hours. 2 hours from the moment she starts walking. So you have to be very careful when they ask whatever question they ask. But it's 3.5 from the moment he starts walking. So you have to read the question very carefully. So if it says how long it takes her to catch up with him, it's just 2 hours. But from the moment she starts, but from the moment that he starts, it's 3.5 hours. Very good problem, thank you. Very good. As you know, there is no way I can cover each and every type of problem in class, so you are really helping me bringing these questions to class. Well done. Is everyone okay with this? Okay, other questions before we start the review? Is there anything else you want to go back to? Mike, is this better?
Yeah, that's better.
Anyone? Yes, please.
Find the domain of a function.
Yes.
It's given x plus 2, x minus 3.
So we have f of x, which is the square root of x plus 2x minus 3, and the denominator is x minus 1. It could not be a nicer problem. All problems are nice. Excellent. Okay, very good question. That's a very good, I'm going to put a problem like this in the test. Thank you. It's very easy. Please, it's very easy. Okay, so here we're given a function and it has a square root. This is our best friend, right? Square root is our best friend. So we have something under the square root. What has to happen here?
The whole thing has to be greater than 0.
Or,
Greater than or equal.
thank you. Do we all agree with this? Because we cannot take a square root from anything else that is not 0 or positive. Agreed? Everyone?
Yeah.
Okay, perfect. Is this table ready? The answer is yes, because it has 0 on one side and a product and ratio on the other. You cannot use a table for this, because it's not a product. This is not a product yet. But here I can. It's a product and a ratio. And this is exactly what I need for the table. We're going to study the sign. It says blah, 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 greater than or equal to 0. So we are studying the sign of this expression. Ready? The variable in the problem is x. The next factor is, or the first factor is, of course. The next factor is, very good. And the last factor is, but what we are really interested in, it's none of the above, but x plus 2, the whole expression. Very good. Good. Excellent. So now, how many x values will you give? And in the correct order? Yes. -2, 1, and 3. Very good. Excellent. So there is a 0 for x plus 2. Where? For negative x minus 3. And for x minus 1. Now I need to identify what happens in the expression or with the expression in any of those. And negative 2. The numerator is 0, so what has to happen? Very good. For x equals 1, the denominator is 0. What has to happen? That's it. For x equals 3, the numerator is 0. What has to happen? That's it. There is no discussion here. All these factors have a positive leading coefficient. They are linear, and they all have a positive leading coefficient. 3 negatives. 2 negatives. 1 negative, and no negatives. See, a problem like this I expect you to solve in less than a minute. Because really there is not, it's just routine. It's not a lot of thinking here, basically. So then, now I have to write a solution. This tells me what to pick. Which sign is greater than or equal to 0? There are only 2. So which sign is greater than or equal to 0? Only positive. So here's positive, and here's positive, which means this and this. Because we are solving for x. We want to find x such that this is positive. So the solution will be x in the interval, or the domain is, because it's a function. So first of all, it can be 0. So I will have to use a bracket at -2, comma, 1, but I cannot use a bracket at 1 because it's undefined. Union, yes, that's it. See, I thought you would really love this because it's like a puzzle. There's really nothing to it. Now, if I change this into minus, what's going to happen with the signs here? It's not going to be this, because this is a linear function with a positive slope. It's going to be this. This is a linear function with a negative slope. Positive to negative. So this would be reversed, plus, plus, minus, minus. Very good question. Thank you. Is this okay?
Yeah.
Yes, very good. Really?
Why do you subtracting?
Because of the equal symbol. 0 is allowed. Yes, Vanessa, please.
So would there be instant where it's like less than or equal to?
Yeah, it could be.
So what would that be?
When I have when I'm asked to solve for or get the negative side,
Like, I mean, like this question.
solve the rational inequality. Blah 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 less than 0.
Yes.
Solve the rational inequality. Yeah. Okay. Anything else you have for me? Anything else? Other questions? Did you work on anything else? Okay, so in that case, I'd like to start my review. So there was a question on what was that function that we looked at? I just want to show the symmetry, or any function. Give me any function to show whether it's symmetric or not. We can look at the previous function we looked at. Okay, so we looked at this function, which is 2x squared minus 50 divided by 6x squared plus 7x minus 3. And when we graph this function, I say it cannot be symmetric because you have a vertical asymptote at -3/2 and a horizontal and a vertical asymptote at 1/3. But to be exact, you will be asked to show the algebraic proof, right? We know it's not symmetric. But I have to determine f of negative x, which will be 2 times negative x squared minus 50 over 6 times negative x squared plus 7 times negative x and minus 3. And I have to show, after I simplify it, whether this equals f of x identical with f of x, or equals the opposite of f of x, or none of the above. So first I have to clean it up and get rid of these negative x squared, because this will be 2x squared minus 50, and the denominator will be 6x squared minus 7x minus 3. So is this identical with the original function? Of course not, because the numerator is identical, but the denominator is not. And so once this gets changed into negative, it cannot be the same. Now, would it be the same with the opposite of the function? No, because opposite of the function would mean minus here. It's not going to be the same with the opposite function. Minus on the function, sorry. So, no, this is no, so therefore, it's not symmetric. Questions? Okay, so the other thing that I would like to review is, so one more time, the sections are 3.5 through 5.7. So this is test 2. Sections, everything we studied from 3.5 to 5.7, and this is what assignments do. I did post your grades. I waited for more than a month and a half, and there are still people who have done nothing from the first part. It pains me to even say it. So I had to enter 0. Yes.
I thought all the web assignments were going to be due like December 12th.
No. I said many times that web assignment is due before each test. If you wait till then, by then you're not going to be able to learn anything. It's going to be way too late. So one more time, I left it open for you to go back and redo other problems if you want to, or raise your grade later. That's why I left it open. But each web assigned homework is due before you take the test. I would personally do it before each class so I can ask questions. Yes, Lynn?
I do have a question.
Yes.
So the percentages, is it graded off the completion or the actual percentages of the?
It's already graded by web assign. I'm just copying the grade from there.
Okay.
So you can go back and increase your grade if you want to, but do not wait. So
you graded everything up to 3.4?
yes, I did not put anything, and I will not put anything for this week or next week. After test 2, I will put the grade in.
Okay.
So you have 2 more weeks. Yes, Mike.
So like if we do the web assignments, does the grade stay the same or does it go up?
You remind me to go back and adjust it, and I will adjust it with pleasure. Yes, I did not synchronize the grades with the WebAssign, so I have to go back. You tell me in class, or you email me and say I increase my grade, upgrade my grade, and I will gladly do it. Okay. Anything else? Anything else? Okay, so let's look at transformations. So here's a question for you. Create a function using f of x equals x squared, right shift of 2, vertical stretching by 4, upshift of 3, and reflected WRT with respect to the y-axis, the x-axis. And you can say, what is this? Of course, they're intentionally not in the correct order. And please remember, when you present transformations, if you're given a function that has to present transformations, if you don't present them like I wrote at the top, present all transformations using the order of operations, the correct order. I can't give full credit. Even if you get the same graph, they have to be the correct order. Okay, so this is the base function. Which one will be first? Because we'll have to put them in the correct order and then come up with the graph, with the function. We don't have to graph. This problem is not asking us to graph. So on x squared, that's the base function. What will be the first transformation in the correct order? Of course. So x minus 2 to the second power. Right shift of 2. Awesome. And that's done. Don't cross it out. I cross it out just to make a point. Next one. Very good. So it's 4x minus 2 squared. Vertical stretching by a factor of 4. Excellent. That's the correct order. It's like you are evaluating. So you can't forget this. Exactly like you're evaluating. Number 3. Yes. Negative 4x minus 2 squared. Done. Excellent. And number 4?
Up 3, so plus 3.
Can anyone give us the vertex of this quadratic function? So one more time. So this is x squared. 2 to your right. Vertical stretching by a factor of 4. Reflect and up 3. 2 comma 3. See, you don't even have to graph. Now you have such a good command and good understanding of this function that you can picture the graph without even graphing it. What about the range of this function? We haven't graphed the function and we have it in our minds. What is the range? Negative infinity to 3. Very good. What is the axis of symmetry? The vertical line passing through this point. X equals 2. Axis of symmetry. Does it have a maximum or a minimum? Good. What is the maximum value? We already know it's the range, right? It's like 3. Good. Excellent. So please remember, I expect you to present the transformations in the order of operations, as we did just now. Great job. I need very good grades on this test. Is that clear? Thank you. Okay, let's look at inverse functions. Inverse functions. Let's say I have f of x equals 3x minus 1 over 4. And g of x 4 plus 3x divided by 3. Are they inverses of each other? What do I have to determine?
That's what you can send.
Great job, thank you. So I have to find f cum g of x, which is f of g of x. If they are inverses of each other, mandatory the answer will be just plain x, indeed, plain x, not x squared, not x over 5, nothing attached to x. If this one happens to be x, I have to find the other one. But if this one, let's say, gives us x squared over 3, do you have to find the other one?
No.
No. You will say functions are
No.
not inverses of each other. Excellent. So then f of 4 plus 3x divided by 3. So let's look at f. F says 3 times whatever minus 1 over 4. So 3. My whatever now is this minus 1 divided by 3. I simplify 3 with 3, of course. I simplify first. And then I get 4 plus 3x minus 1 divided by 3, which is 3 plus 3x divided by 3. I factor out 3 and write in the correct order. And look what I get. What does this mean? They are, yes,
Is this 3 or 4?
this one,
Yeah, under this.
4 minus 1.
Over 3 or over 4?
I'm sorry. It is over 4. Sorry.
Do we have to take out the, do we have to like,
We always simplify. We always simplify as much as possible. Good. So we can simplify. So we don't even need this. In this case, if you want. But I'm going to erase it because I copied 3 instead of 4. Thank you for keeping an eye on that. I wasn't testing whether you were paying attention. Not at all. I just fell asleep at the wheel. And I wrote 3 instead of 4. I like 3 more than 4. Good. So what do we conclude? This is not x. So since it's not x, what do we conclude about f and g? Not inverses of each other. Perfect. Questions? Yes, please, baby. Sorry.
That would have equaled X, then we would have had to find F.
G comp, yes, we would have had to find G comp F.
And then we just would have put F of X aside G.
Correct. Correct. Very good. Okay, so, and yes, please.
What happened to our oh wait, never mind. I got it.
Yeah, sorry about that. This was for. Since it does not equal X, they're not inverses of each other. Yes, please.
So do we have to find g of x? Like,
The other one, no. If this one is not X, you don't have to find the other one.
so in case if we have x, then we can.
Even if the other one is X, we don't care. They both have to be X for the functions to be inverses of each other.
Let's say if we have x, in that case, do
Then-
we have to find g of x?
Yes. We have to find G of F of X. Yes. Yeah. They will be the same. Even if the first one is X, hold your thought. If the first one is X, the second one will be X as well, but we have to show it.
Oh.
Yes, sorry.
so when you ask for inverse functions, when does the.
I'm not asking for the inverse. I'm not asking you to find the inverse.
Okay,
I'm only asking here, are these two inverses of each other?
okay.
So the next question would be, let's pick a function. So give me a function so we can find its inverse. That would have been my next question anyway. Would you like to pick a function?
Let's do a cubic one.
Okay, very good. Excellent. Good job. So let's say x plus 3 cubed minus 2. Is this good?
Fantastic.
Excellent. You know how difficult it is to get excitement out of Bailey, so now he's all fired up. I'm so happy. Thank you, guys. I see you're studying. I see that. Good. So we are asked to find F inverse. Now the question is this. Is this function one-to-one? I don't want to waste my time. Let's picture it in our heads with transformations. This is x cubed, but why do not? What's that? How many? And then? Good. So is it one-to-one?
Yes.
Good. Very good. So it's one-to-one. We know the graph. We don't have any secrets. And then we're asked to graph both on the same coordinate system. Great job. We'll let Caleb suggest other problems in the future. Yes, Marisa?
So this type of problem, do we have to show like every single step, like switching the x's and y?
Yes, please.
Okay.
Please. Good. So first step, please. Good. Y equals x plus 3 cubed minus 2. Great job. Then? Good. Then?
It's also about
Good. Then?
x plus 2.
Perfect.
On both sides.
Excellent. So y plus 3 equals the cube root of x plus 2. Great job. Now? I want to go back for a second to the first function, to the function, the original function. Is it, what is its domain? Good. So what is its range? What will be the domain of this function? That's it. Very good. So domain and range for both. Nice functions. This is what I call friendly. I don't have to worry about it. So you're friendly to me when I don't have to worry about you. So all I want you to be friendly and do the work. And then I stay tight. I don't have to worry about you. Okay, a mental note. Don't you ever put that joke in again. It's not working. Okay, yes.
Could you also write the
Deja.
equation as the
Negative 3.
yeah minus
Yes.
okay.
Yes. So here was a question. So the question was, can we write this as the cube root of x plus 2 minus 3? The answer is yes. However, I have difficulties. Yes? Any questions? Any questions? Any questions? Okay, so I have difficulties writing behind a square root or a cube root sometimes, only because I may, by mistake, extend the root over that, but it's perfect, yes. So we can write it like this, as the cube root of x plus 2 minus 3. But be careful not to extend the square root or the cube root. Okay, perfect. So now we want to graph both. And we can use transformations. When I graph the two functions, what do I have? The function and its inverse. What do I have to graph also? Yes, but we already know how to graph. But what do I have to graph when I graph the function and its? Thank you very much. They must be, their graphs must be symmetric with respect to y equals x. Great job. Okay, so we already know that it goes to the left 3 and down 2. So here's the graph. And it crosses where does it cross? Y0, I can't determine that because I have 2, the cube root of 2 over minus 3. I have no idea what that is. So you're going to have to be happy with what I graph. I don't know if it touches here. We'll have to graph all of them with the graphing calculator. I have to do some calculations whether it touches here. I doubt. So don't make it touching the y equals x. And then the other one. So this. So this is F inverse, and this is F. So let's graph both. So you see my graph is not perfect, and I don't expect your graphs to be perfect either. But just make sure that they are symmetric with respect to the line y equals x. Ready? So